Hello, good evening, everyone. I trust we are all doing well by God's grace. Yes, so if you can hear me, kindly type in the comment section if you can hear me. All right. Yeah, so if you can hear me, just let me know. So I proceed with what we have for today. Yes, so if you can hear me, kindly type in the comment section. Hear me. All right. Yeah, so you can just let me know. So I proceed with what we have for today. Amazing. So yes, you can hear. Yes, so I can be heard, right? Good. So we can start with today's session. Yeah. So our last session, that was day 4. We handled intro to strings and input functions, and we also talked about lists. All right. So we did quite a lot of things here. Yes, and I explained what data structures is to you. We handled intro to strings and functions, and we also talked about lists. All right, so we did quite a lot of things here. Yeah, so when we talk about data structures, so what is data structures in Python? Oh, sorry. What is data structures? Data structures in Python. Or what's okay, yes, what is data structures? Yeah, so data structures in Python are specialized ways of organizing and storing data. So organizing and storing data. Let's take a critical look at that, right? Yes, and we are also saying that. All right, let's continue. So when we talk about data structures in Python, we are saying that they are specialized ways of organizing and storing data. So we realize that when we talked about lists, we were able to store some data, right? We said lists can take all the data types we have, right? So it can take strings, it can take floats, it can take integers, and it can take Boolean values as well, right? Good. So one example of a data structure, right? So built-in data structures in Python. We have lists, we have tuples, we have sets, we have dictionary, we have quite a lot of them. Right. So yesterday we only tackled lists. So today we are going to look at tuples and sets. Then we would move on to practice an exercise. Yeah, so that is all we have for today. So please do all to pay close attention to whatever we have for today and make sure you grasp everything here because once you are able to understand it, it wouldn't be an issue to you, right? Good. So let's quickly get into what we have for today, right? So today we are going to talk about tuples, right? Tuples, because yesterday we spoke about lists. We spoke about lists. So today we are going to continue with tuples, then we move on to sets. Right? Yes. If you are able to understand, if you were able to understand what lists, what the concept of lists in Python is, you'd be able to understand tuples and sets. The only thing that is changing is what is holding the different data to get it. Good. So without further ado, let's just dive in and get started. Right. So when we talk about tuples, let me edit this. This notebook was actually for data science, right? But then it's basically the same thing. So let me, okay, so Python, so tuples. Yeah, so all right, sorry for any background noise. Yes, so let's continue with what we have for today, right? Yeah, so tuples. This is what we are going to discuss for today. This is what we are going to discuss for today. Yeah, so when we talk about tuples, a tuple in Python is an ordered, immutable collection of items. So when we say immutable, yesterday I explained to you that immutable means it cannot be changed, but an immutable means it can be changed. So when we defined lists, you realize that we said that list is an ordered mutable. So one difference between a list and a tuple is list is mutable, meaning its elements can be changed, right? So elements can be changed after creation. But then for tuples, tuples are immutable. Their elements cannot be changed after creation. Their elements cannot be changed after creation. Good. So tuple is an ordered immutable collection of items. Tuple can store elements of different data types. So just like how list can store elements of different data types, tuples can also do same. But the only thing is that tuples are immutable, means their elements cannot be changed after creation. Good. So that is the definition. And um, let's look at the characteristics. We said they are ordered. So elements maintain their insertion order. I explained. So if you insert the first element, it would maintain its order, right? And we also said they are immutable. Yes. And we also said it can store different data types. So just like lists can also store different data types. Good. So we say it's heterogeneous. I believe you guys understand it. It can contain mixed data types. And it's also indexed. So elements are accessed using the zero-based indices. I explained the concept of zero-based indices yesterday, where I said that the first element of the data structure, let's say list or tuple, gets an index of 0. Yes, so I explained that yesterday. I explained it here. That let's say if you have a list like this, the first element would have an index of 0. The second element would have an index of 1. So this is what we call the zero-based yes, indexing. Good. Now let's move on. And lightweight. Tuples use less memory than lists, making them efficient for fixed data. Yes. So you can see fixed data here, right? So you realize that when we're defining when we were defining tuple, we said it's immutable. So elements cannot be changed after creation. So when you have a fixed data, when you're working with a fixed data, you can make use of a tuple. And one advantage a tuple has over a list is that tuples use less memory. You get it? Good. So that is it for what a tuple is. Now, let's look at how we can create tuples. Now, for you to create a tuple, you use parentheses, so open and close brackets, with elements separated by commas. Realize that when we're creating a list, we used square brackets. We use the square bracket. When you're creating a tuple, you use parentheses, as simple as ABCD. Good. So a single element tuple requires a trailing comma to distinguish it from a regular expression. I would explain that later on. So let's quickly create a tuple and let's see. So let's say tuple tuple 1 is equal to. Now, when we are creating a tuple, use parentheses and you separate the elements with a comma. So let's say I'm creating a tuple of integers. So 1, 2, 3. When I print tuple 1, when I print tuple 1, let me correct this. I'll get my output. Do you get it? Good. So this is what we mean by creating tuples. We use parentheses to create tuples. Good. As simple as ABCD. Right now, let's move on to, yeah, and just like I said, tuples are heterogeneous, so they can they can store different data types. You get it? So let me create another cell and name it data. Let me say data science info. I like data science because I'm currently teaching a group of people data science. Right. So if you are interested in enrolling, you can see us after as well. Right. Good. So just like we said, when you're creating a tuple, you use what? Parentheses, right? And we are saying that tuples are also heterogeneous. So you can add or you can insert different data types. So let's say we have Python. Python is a string, so we put it in quotes. Then comma, we have 3.9, just like, oh yes, we created a list like this last time. That was yesterday. I mean last. Pandas is also a library in Python, right, in 2023. So this is a tuple. So you realize that when we use the type function to check the data type of this, let's try and see if it will work. You can see that the output is what? A tuple. So when we change this into square brackets, the output will be what? A list. You get the difference. So we create tuples by using parentheses, open and closed brackets. So that is how we handle that. Yes. Now we are going to continue with something here. Tuples can also be created using the tuple constructor. So I explained that yesterday. So in a similar way, you see how we created this tuple, this 1, 2, 3 tuple. You can use the tuple constructor to create it. But note that you don't just put the values in it. You put the values because it has multiple values. You put it in square bracket, more like a list, right? But then to be at the safer side, just create tuples like this and be safe. But just know that you can also create a tuple using the tuple constructor as well. Right. The next thing we have is how we can access elements, in tuples. And it's basically the same thing. Just like how we worked with lists yesterday, we explained that lists, we do what we call the zero-based indexing. Do you get it? So the first element would have an index of 0, the second element would have an index of 1, and counting in that form. You can also have negative indexing or negative indices. So with that one, you start counting from your right to the left. So the first element to your right would have an index of -1, and then it counts towards the left like that. You get it? So same way as to how we access elements in a list. The same thing happens when you want to access elements in tuples. So let's create a tuple called scores and let's store some values in them. So let's store 54, 34, 89, and 76. Good. So we want to access the first element. So access the first element of the tuple. So when you want to access the first element of the tuple, we are using what we call the zero-based indexing. So for you to access that, how do you handle that? It's basically the same method for the lists. So this time you don't use, you don't do it like this. If you do it like this, you are going to get an error. You are going to get an error. See, tuple object is not callable. Realize that when we're accessing elements in a list, we use the what? The square brackets. Do you get it? So it's basically the same for tuples too. So don't say because you created tuples with parentheses, you are going to access the element with parentheses. No, it doesn't work like that. When you do 0, you get an output of what? 54. So now let's say we want to access the last element of the tuple. So access the last element. So the last element, we can either use what? We can either use, let me provide the index. Yeah, the indices. So this is index 0, this is index 1, this is index 2, and this is what? Index 3. Do you get it? Good. Now you can also do it like this. This side will be, let me quickly do it. Okay, now when you are counting from the right to the left, so the first element to your right will be index -1. You get it? So if you want to access the last element, you can either use 3 or -1. It would work. So when you use 3, what do we get? 76. When we use -1, what do we get? We get 76. The same thing. So that is how we access elements in tuples. As simple as that. So it works like how we did that for lists. Right now, there's a concept we call tuple unpacking tuples. Unpacking tuples. So tuples support unpacking, which is useful for assigning multiple variables at once. So let's see what it means. Let's see what it means. Now, let's say I want to do this. X is equal to 10.5 and y is equal to 20.7 using tuples. This is where the concept of tuples the concept of unpacking tuples comes into play. As simple as that. So with this, you realize that every time we create a variable, we use just one variable, just use one variable name. But then in a case where we have multiple variables, please take note of that. In a case where we have multiple variables, you can do what we call unpacking tuples to do that. So with this, I can basically create two variables, x and y. Make sure that you separate them with a comma. So you get it. Now, xy is equal to, I can now create my tuple using my parenthesis. Then I can now put in the values. So 10.5 and what? 20.7. So analyze it this way. Analyze it this way. When you are doing ordered pairs, when you are treating the concept of ordered pairs, I know in JHS we're taught ordered pairs, so it's not an issue. So ordered pairs. Ordered pairs. Now, you know that actually we have x and y. You get it? So when I have 20.7, it means, sorry, when I have 20.7, it means the x value is, it means the x value, the x, let me do this well. Yes, it means the x value is 20 and the y value is what? 7. Now, we have instances where you have x, y, z as well. So you can have 3 different ones. So let's say 27 and let's say 14. You get it? So this is for x, this is for y, and this is for z. You get it? Good. So when you draw the plane, you can get to know what you're doing. You can get to know what you're working with. So let's say this is y axis, this is x axis. So here y axis, x axis, and z. You get it. Good. So I'm basically all right. All right. So let's continue. Let's continue. Good. So that is what in a case where we want to do something like this, right? We can actually work with that. So let's see something. When you print x, you get your output of what? 10.5. When you print x, you get your output of 10.5. When you print y as well, you get your output of what? 20.7. So this is what we call unpacking tuples. So it is useful for assigning multiple variables at once. Multiple variables at once. So that is the concept of unpacking tuples, as simple as ABCD. Right. So this is a very simple concept, and I think we can try one additional example to digest it very well. So let's say we have once again we have scores. Where did we store scores? Good. So let me just copy this. Let me just copy this. Please don't copy and paste codes, please. Try and type it yourself. I'm doing this for the purpose of, yeah. So we still have scores here, right? Yes. Now I want to get the stats and the last, right? Yeah. So okay. So I want to bring this. I want to introduce this concept to you, which is known as the star operator in tuples. So let me add it. The operator in tuples. Okay. Good. Now, in a case where you have, yes, in a case where you would want to access all elements except the last, right, into a form where you have a list and a value. That is when we use the star operator in tuple. So let me quickly explain that. Now, when I do this, when I put the star in front here and I set stats last is equal to scores, let's see what happens. Um, the code run, but then it doesn't print anything. So let's print stats and let's print last. So look at what happened. When we placed the star here, or anyhow you call it, asterisk here, you can either change this to X, or you can change the variable names. You can use different names. It doesn't necessarily mean this, right? Yeah. So realize that when you put the star operator in front of the two variables, right, what happens is that it would access the first set of the elements with the exception of the last one. The first set of the elements will be stored in a list, so you can see parentheses, and the last element will just be a value. So let's try and see the type. Let's type of last. Let's print them. Let's print this one too. Let's see what happens. Print and print the type of start. Let's see what happens. Good. So you can see that after I printed the first set for the start in the form of a list, when we checked the type was what? A list. So the class is a list. Good. Now, when you do for the last, I told you that it would unpack the last and store it into a form of what? An integer. Right. So when you checked the type, we had what? An integer. So this is how the star operator works. Right. Good. So it is a very useful tool. You get to appreciate it a lot when we get to the machine learning aspect of everything. Right. Yeah. So now let's look at tuple operations. Tuple operations, so just like how we explained list operations, right? We also have tuple operations. Good. So I think we have the slicing syntax too. So it's basically the same for lists. I explained this in detail to you guys yesterday. So if you understand the list very well, the concept is still the same. The concept is still the same. So we don't have to walk you through it again because it's going to take much of our time. You get it? So if you joined yesterday's session and you understood how we access elements in a list using in a range, in the form of a range, you can basically use that same concept to access, to do that, to do the list, to do this the slicing, to do slicing in tuples as well. Right. So let's proceed with what we have. Now, tuples support several operations useful for data manipulation. Right. When you checked the okay, yeah, let me not bring that now. Yeah. So we can also do concatenation and repetition for tuples as well. So concatenation, let's say we have a tuple. Let me quickly create a tuple. So tuple is equal to 1, 2, 3. Right? You can do, and let's say this is tuple 1. This is tuple 1. Let's create tuple 2. Tuple 2. Tuple 2 is equal to 4, 5, 6. 4, 5, 6. Right? Good. Very simple. Now, we would want to combine the two tuples. So tuples, you can also perform concatenation on tuples as an operation on tuples. So you can basically add. So let's create a new variable called combine, and let's add the first tuple to the second tuple. So tuple 1 plus tuple 2. When we print combined, this is our output 1, 2, 3, 4, 5, 6. So we can actually do concatenation on tuples. We can also do repetition as well. So let's create another variable called repeated. And let's repeat tuple 1. So when we repeat it, when you do it times 2, it means you are repeating it. So this is called repetition. So this is called repetition. So when we print repeated, realize that we would have 1, 2, 3, 1, 2, 3. So this is the first print. That was the combined. So 1, 2, 3, 4, 5, 6. And this is the second print, which is repeated. So 1, 2, 3, 1, 2, 3. So you can perform operations on tuples as well. Right now, the next thing we have is membership testing. Yeah, so just like what we did for lists yesterday for testing if an element is a member of a list. The same concept applies in tuples. So you sometimes you would want to test if a member, or sorry, if a list. What am I saying? Sorry for that. Right. So sometimes you want to check if an element is a member of a tuple. It is very simple. You use the in operator. You use the in operator just like what I explained yesterday. So let's say we have tools and we have a tuple. So let's say we have hammer, we have spanner, and we have um screwdriver. Good. Now, sometimes you would want to check if an element is a member of a tuple. Do you get it? So let's see. For you to do that, you use the in operator. So print. Let's see if um which other tools. Let me search. I'm out of I'm out of examples. Tools used in aviation. I'm an aerospace engineering student, so let me let me check an example. Okay, so we have pliers. So let's check if pliers is a member. So pliers, you use the in operator. Pliers in tools, because tools is a variable that is storing this tuple. So when we print this, you realize that it will return false. It will return a boolean value false, which shows that pliers is not part of the tuple tools. Now let's check. Let's change this into hammer, but then let's use capital H. When you check this, it will be false because the hammer we have here is small h, lowercase, not uppercase. Right, so let's do what to analyze that as well. But then when you change it to small h, it will change to what? True. So that is it. Sometimes you would also want to know the length of a tuple. The concept is basically the same. You use the length function. So length of tools, what do you get? Tools has one, two, three elements. So the length will be what? Three, right? Same concept. Now we have tuple methods. We have quite a lot of them. But then for the sake of time, we are going to treat a few, right? So in some cases, let's create a tuple called data. So data is equal to, and let's put in values 10, 20, 30, 20, 10, 70, 90, 80, right? Good. So this is a tuple. Now we would want to use a method. Yes, we would want to use a method, a tuple method. Right. So once again, sometimes we will not get the time to walk you through everything. So you can search methods of tuples in Python. Right. So it will list everything for you. I mean, you can search. You have to also cultivate the skill of researching because you might not be able to know everything. So good researching skills could also help you as well. Right. And even today, AI has made programming very simple, very easy to understand. Do you get it? But then if you are a beginner, if you are practicing how to code, please don't totally depend on Chat GPT, no, or Gemini or any other AI. Practice it and learn it, understand the logic. Do you get it? So that once it generates it for you, you can get to use the logic to analyze and know that, oh, this code is not working because I have to change this and that. You get it? Good. So we have one method called count. So count into bracket value. Now, this method returns the number of times a specified value occurs in a tuple. So in a case where we want to know the number of times this element 10 occurs in this tuple, we can use the count. So let's create a variable called count 20. So we would want to count the number of 20, like the element 20 we can find in the tuple data. So when we want to do this, once again, I told you that whenever you are dealing with methods, when you are dealing with methods, you first type the variable name. You first type the variable name, right? Then you bring your dots, so dots, and then you add the what's the name? The method. Do you get it? You add the method, as simple as that. So this is a very simple concept. Let's quickly move on. So I would have to call the variable which is storing the tuple, which is what data. Then I'll bring my dots. Then I'll append the method. So count. Please note that it's in small letters. So count. Now count takes a value in the bracket. So what are we counting? We are counting the element 20. Do you get it? So when we print count 20, what do we get? We get an error. Count. Yes, so I made a typo here. So let's correct that. So you can see that the output to be 2 because you have 2 of 20 in this. Now when we print, let's do counts. Let's do counts. Let's count. Let me add one more. Let's count 10. So here it will be data dot count 10. Right. Let's print count 10. Now when you do this, you realize that we have 3 of 10 here. 1, 2, and what? 3. This is it. You get it? As simple as that. So this is one method. This is one method. Yes. And another method is the index. I think it's here. Yes, index. So this method returns the index of the first occurrence of the specified value within the given range. If the value is not found, it raises a value error. Okay. Now let's try something here. Let's try and see if we want to count. No, let me create a new cell to do that. Let me create a new cell beneath to do that. So let's say count. Let's create a variable name called count 500. Now ideally 500 is not part of this tuple, but then we want to try something. Data dot count 500. Now let's print count 500. It gives you 0 because there's no element 500 in this tuple. Right. Good. So that is how interesting Python is. You get it? Good. Now let's try the index. Now let's say we want to print the index of this 30. This 30 here. So with that one, you use let me copy this again and paste it here. So let's say we want to know the index of 30. Right. So that one you use the index method. So index, and you put in the value 30. Now let's print index 30. Now the index is what? 2. The index is 2. Why is the index 2? Because we deal with what? 0 based indexing. So the first element is index 0, second element is index 1, index 2, index 3, like that. So at index 2, what do we have? At index 2, we have what? 30. So the index of 30 is what? 2. As simple as that. Right. Now, the last part for today's session, since tuples are immutable, are immutable. You say immutable when you can't change the elements. Do you get it? In the structure. So since tuples are immutable, they lack methods like append or remove. The reason why, you see, append is to add an element to the last part of the structure. Do you get it? So you realize that when we're dealing with lists, we worked with append. So when we appended 50 to this data, 50 was added to the last part of the list. Now, we were able to do append and remove because lists are mutable. So it means that their elements can be changed. But because tuples are immutable, their elements cannot be changed. So you can't do append or remove because their elements, tuples are immutable. Right? Good. Now, in some cases too, you would want to convert a tuple into a list. So let's say we create a new variable called data list, and we put in some values. So let's say 34, 56, 78. Now, when we do data lists dot append, let's say 30, no, append 89. When we print this, you get an error because you say tuple object has no attribute append. Once again, because tuples are immutable. So they lack methods like append or remove. You get it? So in a case where you want to still append, what you can do is you can convert the tuple into a list. Do you get it? So what we can just do is we can create. Okay, now let me do it well. Right? The same error. Now we want to convert this into a list. So data underscore list. Now we realize that we have the list. Yesterday I mentioned it here. When you are creating a list, when you are creating a list, when you are creating a list, where is it? Okay, now let me explain. Let me show it to you here. The list function. Yes. So the list function. So the list function in Python is used to create a new list. Right? You can also use it to convert other things into a form of a list. So you can convert tuples into a list as well by using the list function. Do you get it? Then you type in the tuple, the variable name for the tuple that you want to convert it into a list. So now when you print the type of data list, you now realize that it is what? A list. Do you get it? Good. It is a list. But then when you print the type of data, data is still what? A tuple. Do you get it? Now, this variable name is performing an operation where we are converting the tuple into a list. Do you get it? So if you do this, it now becomes what? A list. So now data list is now in the form of a list. We can now do append. So you can do data list. Data list. Okay, first let's print data list. Print data lists. Do you get it? It is now in the list form. Now we can now perform our append. So data list dot append. What do we want to append? We want to append 50. So 50. Okay, print data list. Will it actually append? Yes, 50 has been added. You get it? Good. So this brings us to the end of the tutorials on tuples. Right. Now, the next one we have is sets. Sets. Sets is a very simple concept. Right? It's a very, very, very simple concept. And when we talk about sets in Python, sets is an unordered. Please note the definition. When we were defining tuples, we said tuples are what? Ordered. They are ordered immutable. Lists are ordered mutable. Let's take note of that. Lists are ordered mutable. But then sets are unordered mutable. So when we say they are unordered, it means elements have no specific order and indices are not applicable. So you realize that because tuples and lists were ordered, if something is in an orderly way, we can find a way to index it. But if it is unordered, then it means we can't index it because actually their elements are not placed in specific order. So we can't assign it as a specific index. So sets indices does not apply. They are not applicable. The concept of indexing is not applicable in sets because sets are unordered. Now, sets are mutable. Their elements can be changed. So you can add and remove elements. And one characteristic of a set is that they have unique elements. So when you create a set and you have duplicates, like you see when we're creating tuples, we created some duplicates here. We had 10, 10, 10, right? In sets, you can't do that. So their elements are they are unique. So when you have duplicates, it will automatically remove them. So unique elements, duplicates are automatically removed, right? Yes, and they have quite a lot of, characteristics, right? So without explaining too much, I want to use this 7 minutes to explain the concept of sets, right? So this is how to create a set. You use curly braces to create a set, just like how we use the curly brackets when we are doing mathematics. Yes. So sets are created using curly braces with elements separated by commas. Or you can also use the set constructor, just like the list constructor, just like the list constructor we used here. Just like the list constructor we used here. Very simple. Right. So when you want to create a set, so let's say um let's say the set constructor, when you want to create an empty set, so empty sets, empty sets, you can basically use the set constructor to do that. So let's see the type. Realize that it's a set. Do you get it? Good. Now let's create a set of odd numbers. Set of odd numbers. So odd numbers, a set of odd numbers. So sorry. Um 1, 3, 5, 7, 9. You get it? So this is how we create a set. Now we said that sets store unique elements. Do you get it? They store unique elements. So when you're dealing with integers, you have to deal with integers. When you're dealing with um let's say sets of strings, right? You make sure that all of them are what? Strings. So God, comma, is sorry, is so these are all different strings. You get it? Please take note of that. Please take note of that. So sets their elements are unique. And we even said that let's try something out. We even said that because their elements are unique, it automatically removes duplicates. So if you have, let's say, let's create a set of duplicates and let's see what happens. 10, 10, 10, 20, 30. Now when you print when you print set, when you print this, realize that it automatically removes the duplicates in it. It automatically removes the duplicates in it, as simple as ABCD. Right? So sets have very unique elements. So assuming I add, let me add 9 here, right? And let me print set strings. Realize that realize that the 9 this is why, this is why, what's the name? We say um this is why we say sets are unordered. Their elements have no specific order. Realize that when we when I did is good, God is good plus 9. Realize that when I printed it, 9 is now appearing first. So this tells you that the this tells you that sets, their elements are unordered. Please let's take note. Let's take note of that. Right now, you can create a set of tuples. You can create a set of tuples. Don't be confused, right? So let's say we have coordinates. We have coordinates. So let's create a variable name called coordinates. Coordinates. Right. So coordinates. So I can store one, comma. This keyboard is worrying me. Oh. It's very difficult to adapt to new. And we have 3, 4, 5, 6. Get it? So when you print coordinates, you get a set of what? Coordinates. Right. Good. Now, we also defined that sets are mutable. So take note of that. We can access and modify sets. We can access and modify sets. So since sets are unordered, they do not support indexing or slicing. Instead, you can iterate over elements or modify the set using specific methods. So with this one, when you want to access because it's unordered, because you don't really know, because it's unordered, you wouldn't know the specific index to assign to the elements, because we said unordered elements have no specific order and indices are not applicable. So realize that because tuples and lists are ordered, we were able to access their elements using using their indices. Do you get it? Good. So same thing applies to tuples because tuples are ordered. But here's the case: sets are unordered. So when you want to access their elements, you can use the for loop to iterate. But then we haven't gotten to loop, so I don't want to confuse you guys. So when we get there, I'll come back and explain it to you guys later on. Right? Yes. So um we can also modify sets because we said sets are what? Mutable. So if they are mutable, it means that we can change their elements. So we can add, right? We can update, we can remove. You get it? So let's create a set called ladies. So ladies set. So ladies, it will take string. So Juliana, Amanda, and Linda. So if you want to add, so you can just do ladies dot add. So ladies dot add. Which lady do I want to add? I want to add Lizzie. Okay. Right. So sorry. So when I print ladies, it will be added. to be added. So Juliana, Lizzie, Amanda, Linda. So you can see that when I added Lizzie, it didn't put it at the last part, or it didn't really have a specific way. It placed it at the second position, that is index one, because Juliana is ideally ideally if it were to be ordered, if sets were to be ordered and have indices, we would have said Juliana has index 0 and Lizzie has index 1. But because it's unordered, you see, when we added Lizzie, it's just placed at a random place. When we print it, you see, it has, you get it? Yeah. So sets are unordered. So it has added the element, but then not to a specific position. We can also update. We can also update. So the update method is basically a built-in set method that adds elements from an iterable. You can research about that. So if you want to add, when we say an iterable, we say iterable. Iterable is basically an adjective. It's basically an adjective for let's say an element you can iterate over. But because we haven't gotten there yet, I don't want to bring them here to confuse you. So let me just show you what it will do. Updates. 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 Open and close brackets. So updates. Um Updates Juliana. Juliana. Jillian. Let's print ladies. So you can see Juliana, you can see Gillian, you can see Linda, Lizzie, Amanda. Right. Yeah. So there are quite a number. There are quite a number. You can use remove. Right. You can use remove too, because we said sets are mutable. So you can remove. So ladies dot remove. Who do we want to remove? We want to remove Lizzie. Note that Lizzie is a string, so put that in. So print ladies. So it has removed Lizzie from the set. You get it? Yeah. Oh, there are quite a number of them you can check. Now, set operations. Set supports mathematical operations like union, intersection, difference, and symmetric difference, which are useful for data analysis tasks like comparing data sets. So don't worry about the latter part. I realize that in senior high school or even junior high school, when we were working with sets, we looked at concepts like union, intersection, and difference. Do you get it? Yes. And let's quickly do that here. So let's say we have a set. So let's say set A. Set A is equal to 1, 2, 3, 4. Okay, let me just end at 4. All right. And we have set B. Set B. Um Set B. Let's use 3, 4, 5, and 6. Good. Now we want to perform union operation. So we want to perform union operation. Now when we want to perform union operation, let's create a new variable called union set. So when we want to perform union, let me go to Canva. Let me explain that. So if let's say you have a set, let's say x is equal to, I don't know why this thing of late is fooling like that. I just don't know why. Let me use this. Okay. Okay. So let's say x is equal to set 2, 3, 4, and then 5. I don't know why this thing is lagging. I just don't know why this thing is lagging. Let me quickly solve. That's and you have y is equal to 1, 2, 3, 4, and 6. Now, when you want to find x union y, x union y is basically equal to you append, like you add the two, right? So it starts from 1, 2, 3, 4, 5, and 6. So this is the union. Now, when you want to find intersection, intersection is more like elements that could be found in both sets. So intersection would have 2, because 2 you can find 2 in x and y, 3, and what, 4. This is it. So when you want to perform intersection, when you want to perform union, you first type this one, and then you use the pipe symbol. Pipe symbol. This is the pipe symbol. Check the I don't know how your keyboard looks like, but then look for the key. Look for the if you are using Windows, look for the backslash key. Look for the backslash key. On top of it is the pipe symbol. So it's that straight vertical line. It's called pipe. So let me check if I'm right. I was actually taught this when I was in first year. Let me confirm. Let me confirm. Um, pipe symbol. Yes, I'm right. So it is also known as the vertical bar. Yes, it's also known as the vertical bar or the vertical slash or pipe, or some people call it pipe symbol or upright slash. It's a symbol used in mathematics, computing, and other areas to represent a specific type of logic or operation, depending on its context. So in Python, you use the pipe symbol to do a union set. So when you print union sets, this will be your outputs. You can see you have 1, 2, 3, 4, 5, 6. Right. So that is how we use the union set. Now, when you want to do intersection, you use let me check this before I make a mistake. Yes, I'm right. So ampersand symbol. So use the ampersand symbol and to do intersection. So let's let me create intersection. So when you want to create intersection, so let's say intersection set is equal to set A ampersand and set B. Print intersection set. You can see 3 and 4 because 3 and 4 could be found in both sets. Right. So these are some operations you can do. You can also work with difference. Now let's look at what difference will do. Let's create a variable name called difference. Now difference, you basically use the hyphen. So set A hyphen set B. Let's print difference. Now we are getting 1, 2. We are getting 1, 2. So basically what the difference do, it creates a new set containing elements in set A that are not in set B. So it would create a set containing elements in set A that are not in set B. So that is what different does. So if you check here very well, elements in set A that are not in set B, are what? 1 and 2. Because 1 and 2 are in set A but are not in what? Set B. So that is where you can have what? 1, 2. So basically the difference would create a new set. It would create a new set containing elements in the first set that are not in the second set. That is what the difference element does for you. Now, we also have something we call symmetric difference. So let's try symmetric difference. So symmetric difference, you use caret. Yeah, today the mind this one works. Caret symbol. I'll say that I'm the king of punctuations. Yes, I'm right. So the caret symbol, this is it. Caret symbol. So let's do symmetric difference. Symmetric difference. So let's create a new variable called sim diff sets. Sets a symmetric difference. Caret. Caret can be found on the check number 6, right? 6. Check, you can see it on top of it. So set B. Let's see what the caret symbol does. Print sim diff sets. We have the output to be 1, 2, 5, 6. 1, 2, 5, 6. Now, what symmetric difference does? Let me copy and paste this here so that you guys would know what we are doing. Now, what symmetric difference does is that symmetric difference would create a new set containing elements in either set A or set B, but not in both. Take note of it. Symmetric difference would create a new set containing elements in either set. So either set A or set B, but not in both. So one, right? What symmetric difference is doing is that it will take all the elements in either of the sets, but then it would take out elements that are found in both. So which elements can be found in both set A and set B? We can find what? 4. We can find 4 and what? 3. 4 and 3. So it means that it would create a new set with what? 1, 2, with the exception of what? 3 and 4. 3 and 4. So that's why you can see 1, 2, 5, and what? 6. That is why you can see 1, 2, 5, and 6. That is why you can see 1, 2, 5, and 6. Cool. So that's what symmetric difference does. Now, the last thing we have for today is set methods. Set methods. So there are quite a lot of methods in sets. So you can research them. You can research them because I've taught you how to use methods. So you type the variable name, you bring your dot, and you add the method. Right. So depending on what the method, what kind of operation you want to do, you select the right method to do that. So we have add. So adds an element to the set. We have clear, removes all the elements from the set. We have copy, returns a copy of the set. We have a lot of sets here. Right? A lot of sets here. So a lot of set methods here. Do you get it? So depending on the operation you want to do, you can basically do that. Right. So let's see. Um let's see if I can okay, let's use clear. Clear removes all the elements from the set. So let's say I want to clear all the elements in set A. So what I'll just type is I'll type the variable name, which is what? Set A, and then I'll use my what? My method. So print set A. Your output will be what? An empty set. An empty set. Realize that when we started, I taught you guys how to create an empty set. You create empty sets so when you do something like this, it's an empty set. So you can see that we've cleared everything in the set. You get it. So you can explore. Right? Once again, look at the number of methods here. We can't finish them. So you just have to know the logic behind it. So that next time when you want to use it, you would understand it very well. Get it? So this brings us to the end of today's tutorial. I have an exercise for you. You guys can try it out. Right? We'll record a different session altogether, solving all the exercises for you. So this is the question which says that create a contact organizer that takes user input for exactly 3 contact names, and it stores the contact names in a list, converts the list into a tuple and a set, and performs operations using strings and operators. Specifically, you use string concatenation to display the results, convert input names to title keys, and combine the first contact names into a single string for display. So this is just an exercise containing a series of tasks, right? So the first one is to create a contact organizer that takes user inputs for exactly 3 contact names. The second task is you store them in a list. The third task is you convert the list into a tuple and it proceeds like that. Right. So that brings us to the end of today's tutorial. Tomorrow, we are going to learn dictionaries and control flow. Please, control flow is a very interesting Python topic. This part, there are repetitions, less tuples, and so it makes the tutorial quite boring. You get it? Yeah. So from tomorrow, we are going to do more applicable stuff. We are going to do more things that would make you appreciate Python a lot. You get it? So do well to show up for tomorrow's session, and please make sure that if you don't understand any concept, try and research. Right? As a programmer, you should know how to research, you should know how to solve problems. A good programmer is not just a programmer who can write all codes off head. No, you have to learn how to research and solve a task. Do you get it? It's all part of the skill, right? Good. So thank you very much for participating in today's session. Until then, take care. Bye. Have a lovely evening.